All right, we're going to get started in a few minutes. We're nearly 100 participants, so really great turnout. We'll be turning it over to Jack Smith here in just a couple of minutes. Those of you with questions, just pop them in the chat there. All right, Jack, are you on? You ready for me to stop sharing so you can share your slides?
I am, yes. Go ahead. Thanks, Andy.
Thank you all for turning out, and let me introduce Jack Smith.
Hey, good morning, everyone. I'm Jack Smith. I'm the chief of the State Fire Academy here in Ohio. Want to thank everybody for getting on to the presentation today. As most of you are probably aware, this week has been designated by the Fire Department Safety Officers Association and the I-Chiefs and National Volunteer Fire Council as Safety Stand-Down Week with a focus on lithium-ion batteries. And so in support of that initiative, the Marshal's office and State Fire Marshal Kevin Reardon, we wanted to provide this panel discussion today to help support getting some of that information out to you all, and also have a panel discussion. So at the end, we'll have a roundtable of questions from the audience. So on the panel today, myself and Marshal Reardon, as well as Alex Schraiber, who is a researcher with Underwriters Laboratories, both the Fire Safety Research Institute, which most of us from the fire service are aware of the work that they do with fire dynamics and things that are relative to firefighter training on the fire ground. Alex actually works with the other side of the lab that does research on consumer products to make sure that your coffee maker and your microwave aren't going to catch your house on fire. but they've also been delving into the lithium-ion batteries from the consumer product side of things. So she'll go more into that. We also have Captain Evan Balcome from FDNY, who has been heavily involved in lithium-ion battery responses in New York City. And then also Captain Hunter Clare from Peoria, Arizona, just outside of Phoenix. And he'll be sharing experience that he had with a solar panel farm and the energy storage system there that had a significant explosion. I'm going to go ahead and share my screen just real quick. So Andy, tell me if for some reason that doesn't come up. So you should be seeing the same logos, and then
Yep, looking good.
okay. So I'll show this throughout the event today, but there's a QR code. So if you guys want a couple hours of Con Ed, just hold your phone up to that QR code and turn on like you would take a picture. You don't actually have to take the picture if you've not done much of this. If you just scan that with it in camera mode, there should be a little yellow button that pops up on your screen, and you can touch that yellow button and it will take you to a little web form that you can fill out to apply for Con Ed. If you don't have your phone handy for driving, if you don't have a phone that's got a camera on it, you can also go to that link there at the bottom, the WebOFA at com.ohio.gov. And I've also put the link at the beginning of the chat. So there's probably a lot of stuff in chat, in the chat function here on the Teams platform already. But if you scroll to the top of that, I put the link for the safety stand down brochure that's got all the videos from this week in it, as well as the link to Underwriters Labs, their Fire Safety Research Institute. If you guys have not been on that website and wearing it out, you really need to spend a lot of time on that. There's a lot of fabulous information. So if you're a training officer, if you want some content for the next month or so, there's plenty of stuff on there for your folks to be able to work through. And then also the WebOFA link to get to Con Ed.
Jack, just a second. Chief
Go ahead.
Ian Emmons is asking Chief Smith, are those CEs usable for FSI hours or only for FF?
I believe only for firefighter, not safety inspector. Okay. Okay, so kind of to kick us off a little bit, I'm going to go to the next slide here. This discussion's been kind of building through the fire service and through our society in general, just over the last few years as we have more electric vehicle fires and more energy storage system fires associated with that. And you know, some people want to say that this is the boogeyman and that it's going to be the end of the world. But, you know, as kind of preaching to the choir, those of us in the fire service, we have been managing and responding to the flammable and explosive hazards of gasoline for 100 years. Kerosene 50 years before that. We've been managing the risks and hazards associated with nuclear power for the last 60 years. And this is just another energy source, right? And so as we learn more about it, the science and engineering behind it, dispel some of those myths and help us understand what we're facing when we get on the scene of whether it's a car fire or an energy storage system, then you know, that will help us to make more educated tactical and strategy decisions on the scene. The slide that I've got up here is from the Ohio Manufacturing Association, and it just kind of shows where Ohio as a state is going in economic development. Actually, we're being told right now that if you lump together electric vehicle assembly plants, which is a lot of what you see there, electric or lithium-ion battery manufacturing and lithium-ion battery recycling. If you lump all that together as a technology, Ohio ranks third in the nation currently in this technology from an economic development standpoint. So We are going to kind of talk at the very basic level of how batteries are developed, how they're built, what their internal components look like today, but then we'll kind of talk at a little bit higher level as well, so that we understand some of the engineering behind these products at the smaller level. But here in Ohio, we're obviously our bread and butter is car fires, right? Uh, you know, car fire on the side of the highway has a little bit of exposure with some of the smoke, and we understand the hydrogen fluoride gas that is being put off in that smoke. But as I've been talking to my colleagues at FDNY, just by virtue of call volume that they are seeing throughout the city, they're really out in front of this with UL. And as far as developing strategies and tactics for that, and I'll let Capt and Balcome get into that a lot more. But a car fire, even on the side of the road or in a single-family house, is one level of challenge for us. But as I talked to Chief Mike Mays from the hazmat unit there at FDNY, and Chief Frank Lieb, who's our training chief, they're more worried about a whole bunch of electric vehicles 5 stories underground in a parking garage. And one of the things that we both share concerns on is you think that you've got one battery in a car. Now you multiply that times 20 batteries and put them on top of a bus. That's another level of challenge. Now put 40 of those buses in a bus garage all on charge at the same time. That kind of takes it to the next level. And the marshal's office, we've been traveling around the state to some of these facilities that you see here on this map. Now imagine half of a Home Depot or a Lowe's, and I only use that as a kind of a baseline because we're all in those buildings all the time. Think about half of one of those buildings full of batteries from floor to ceiling in rack storage, and that's what we're seeing in some of these factories. So exponentially larger hazards and risks that we're trying to understand how to properly, looking from an emergency management standpoint, prevent, prepare, mitigate, respond, and recover. How do we handle these types of situations in this emerging technology? And that's really what it amounts to. And the fire service, like I said, we've been managing various forms of energy for long periods of time. And as new things come about in society and technology, we adapt and develop the capability to respond to those. And so that today is just a component of that as well, as far as the educational piece. I'm going to go back to the QR code for just a second, let you guys have a second opportunity to hit that QR code real quick. And Andy, did you see if the marshal is on yet?
Yes, he is.
Okay. With that, I'm going to stop sharing my screen and that over to State Fire Marshal Kevin Reardon for some comments.
Thanks, Chief Smith. Thanks, everybody, for joining us this morning for this very timely and certainly very relevant topic of lithium-ion batteries. I echo everything that Chief Smith has already said. We are so far ahead of what we know now about the lithium-ion battery problem than we were even a year ago. The amount of knowledge and research that's been created in just the last year has been incredible. This has helped us be in a position to be able to put this webinar on for you, to share some information with you from some of the best, most experienced folks in the United States that have dealt with this problem for quite a while. So thanks for being with us. If this is popular, hint, hint, if this is popular and you like them, we might continue to do these in the future on a host of different topics. So thanks for being with us. And I certainly hope you gain from this a lot of knowledge and you get thinking about some things that it's going to affect you at the local level, what you're going to do when you're faced with one of these issues. So thanks for being here, and I'll turn things back over to Chief Smith.
All right. Thank you, Marshal. Alex, I haven't seen Alex Schraiber. Are you online yet?
Yeah, I'm here.
Hey, good morning.
Good morning.
So I introduced you a little bit already, but I'll go ahead and let you kind of fill in the gaps there and correct any errors that I may have had, and go ahead with your presentation. So welcome. Thank you.
All right, thank you. I appreciate the introduction and the opportunity, Chief Smith, to share with you all today. So I'm going to try and share my screen. Hopefully you can see it. Let's get this in
Yes, we can see it.
mode. Is it full screen now? I hope so. Okay. So as Chief Smith had shared, I'm Alex Schraiber. I manage our fire research and development group within UL Solutions. So we're more of the commercial side of house for Underwriters Labs, but we do work very closely with the Fire Safety Research Institute. And certainly this project, the two projects that I'll share today were a collaboration between our organizations, but we also have this commercial testing experience. So my background for the past 6 years has been doing a lot of different types of fire testing, many of them being batteries, from small format batteries all the way up through full-scale energy storage system testing. So that's the perspective that I can bring here, is that testing perspective. And when it comes to tactical considerations, I will be able to share some of what we've developed. But that's where I really lean on people like Captain Clare and Captain Balcome to fill that in. So I will start with an introduction to a couple of field incidents that have occurred related to residential energy storage and electric vehicles. To me, as someone assessing risk of fire hazard, whether the batteries are in a pack with tires on the floor or mounted to the wall, the resultant hazards when things go wrong are really quite similar. So we'll treat those similarly today. And then I will share the high-level results from two different full-scale projects that we conducted last year. One focusing more on fire hazards and the other more on the explosion hazard. And then some overall response considerations that have been developed as a result. I will not be able to watch the chat during the presentation, but if you want to interrupt with questions, that's fine by me.
I will read the chat for you and interject with the appropriate at the appropriate time.
Okay, thank you. I appreciate that. So these two incidents I'm going to use to set the scene. One occurred in 2019 with an electric vehicle in Montreal, Canada. I forget if the vehicle was charging or not, but at some point the battery in the vehicle failed, and the accumulated gas that can be released from lithium-ion batteries ignited and ejected the garage door across the street. This is the scene that the responding fire company saw. The homeowner was first aware of this incident when he heard the loud noise. This other incident occurred a couple months ago in Colorado. You may be familiar with it. This was a similar incident where a hybrid Jeep Wrangler, the battery had failed. The homeowner reported a strange smell. And when the responding company from Mountain View was looking for smoke, they responded. There's no smoke showing. 3 members made entry. And then during some firefighting operations with that accumulated gas, a deflagration occurred. And I can share this video that we've been provided, and a lot of appreciation and gratitude to the Mountain View Fire Department for allowing us to share this. So very luckily, no one was seriously injured in that incident, but you can understand by the garage door knocking off the acting battalion chief's helmet that this was, a couple steps different, or if something was different, this event could have been more serious. So we're trying to learn what we can from that sort of a near miss, and provide context to the work that we're doing. Just last week, this week, there was a residential energy storage system fire in a garage. No one was hurt in that incident as well, but there was significant damage. With all this in mind, I'd like to orient this discussion and presentation with this concept of risk. So we have risk defined as both, a product of frequency as well as severity. These incidents, based on the data that we've accumulated, and we're developing a database internally. One of the engineers on our team, Dr. Veronica Kimmerly, is developing a database to track these sorts of incidents. The frequency is low, particularly for EV and ESS, due to the engineering involved and the standard testing that they typically go through, and the level of safety features that are installed. But I certainly don't need to explain to this audience that the situations you're responding to are not when everything operates as intended, but rather when something goes wrong, the situation that, the manufacturer says was never possible, or no one really saw coming. So that, while these incidents are rare, our research has been focusing on severity and what that consequence can look like. So with rare frequency, but potentially severe consequence, that's where we wanted where we've been conducting this full-scale research to develop whatever guidance and data that we can to help bring that severity piece down. And severity is going to be driven by a number of different things: the location of the events, the extent of thermal runaway propagation, just how many batteries are involved, whether it explodes, whether it ignites, and those situational things. That's one of the reasons e-mobility has some of these very severe events, because there's all these complicating factors around it. You have your means of egress blocked or things like that. So with that in mind, the first project that we conducted last year looking at residential ESS response was sponsored by the Department of Energy. They issued this grant to the International Association of Firefighters, who contracted the testing piece of that to us at UL Solutions. And we worked very closely with our friends at FSRI to execute the work and interpret the results to make sure we're getting the most out of it. We also had an advisory panel that helped guide this work for us to make sure that the methods we were using and the instruments we were using will provide the most valuable data. And they're also helping us develop the considerations. For that, I do want to acknowledge Captain Hunter Clare for his contributions to this, because it's really been very meaningful and very helpful contributions. This report for this project is in draft now. It should be out within the next month or so, and at that time I can share it back with you all. The test setup that we used for this project was this 2-car garage. Yeah, you can see pictured down here in the bottom left. We did this testing in our large-scale test facility just north of Chicago in Northbrook, Illinois. This facility is often used for warehouse testing for fire suppression systems, but it's a big open space that we can do all sorts of testing in. So we had this 2-car garage. You'll note that it's built out of a steel structure. This was because we needed to mitigate the explosion hazard potential to test safely indoors. And for this, we were really focused on the fire hazard and the surrounding measurements. So we use this 2-car garage because it's a common type of new construction, and it's one of the allowable installation locations according to the International Residential Code. We conducted 4 tests. The first was a baseline that only included this Group A, we call it commodity. The Group A is it's plastic cups and cardboard stacked in a very specific way. It's very common as a standard fuel for warehouse testing. So we used it here to represent all the assorted things that could be in your garage. Certainly, my garage is not that neat, and I imagine very few people's are. So we had one test as a baseline with just that commodity, and then we had 3 tests where we introduced thermal runaway into these mock-up energy storage systems that you see pictured in the center here. Each of
Alex,
these
I'm not
units,
sure if this is a appropriate question for you
Sure.
or not. Do you know if the upcoming fire and building codes will require gas detection for hydrogen fluoride in the area of the storage batteries?
I have not heard of that type of requirement. It could happen, but I have not heard of that coming out. The detection requirements that I've heard being considered are more related to smoke or heat detection, which each have their complexities in a garage, because you often have unconditioned space and a number of different nuisance sources. But the detection and notification piece is definitely an active topic of discussion.
Marshall, would you like to chime in on that?
Yes, we are in the process of reviewing the current Ohio Fire Code. I know we've talked about a requirement like that. We're just not that far yet. We will probably take our lead from some of the national standards that are out there and see what's going on in other states. But as locals, remember, in Ohio, you have the option to go more strict than what the Ohio Fire Code requires. So that's always an option. If we can't reach a consensus to put something in the code at the local level, you have that option to add that yourself through the authority of the Ohio Fire Code. So just get that out there. We're looking at it, but if we can't reach a consensus, you still have that option locally.
Thank you. So building off of that, some of the instrumentation that we have installed to monitor this test, we were monitoring temperature, gas composition. We had some laser-based HF measurements at these locations in the more or less down the length of the driveway. And then we had some thermal imagers as well as handheld gas meters at some key locations around the structure. Based on the input from our advisory panel and the scope of this project, we were focused on ventilation operations more so than suppression operations. And the ventilation operation that we used in 3 of the 4 tests was the inverted V cut that you see pictured here on the right. What you'll see in the test videos that I'll share is that we pre-cut this garage like this inverted V cut, and we replicated this spark behavior with a pyrotechnic, kind of like a rock concert, instead of having a saw during the testing, because we were aware of the hazards and wanted to control the variables and not send someone up to do this operation. For our 4th test, we simulated ventilation and entry through the door that would be attached to the residence, and we'll see how those scenarios looked. So I'll give a high-level overview of what happened in each of these 4 tests and how that led us into the next project. And if I'm going too slow on time, do please let me know, because I get excited about this stuff and I can keep talking. But so this first test was our baseline test, and what you'll see in this video is that the smoke before ventilation was light in color. It's buoyancy driven, it's moving up. Limited in quantity, and as these sparks are shot, the gas does not ignite. We know smoke to be unburned fuel, but not very readily ignitable in this case. As that inverted V cut is pulled in, which you can see, the smoke starts to come out. With this increase in ventilation, the smoke gets darker and thicker, but it took 10 to 12 minutes before there was any flaming out of that vent. For test 2, this is where we started to use the batteries. And in this case, we started the event with thermal runaway in the battery. So that was the starting source for this event. And we had, I'll play a time-lapse video here. We forced thermal runaway in a single 18650 cell. And based on the construction of our mock-up unit, thermal runaway propagated through and it did not immediately ignite. So you can see this is a time-lapse that takes 16 minutes of our test and condenses it down to about 30 or 40 seconds. You see that steady release of gas as more and more batteries are involved. And in a moment, you'll see that that gas ignites. So this was self-ignited. The batteries are able to generate those ignition sources. And how severe that deflagration is going to be is going to depend on how many batteries are involved, when it ignites, and how it's confined. So as I mentioned before, we
Alex,
Yeah.
can you comment as to how the hydrogen fluoride gas is generated? I don't know if this is a good opportunity for that, or we can wait on that if it makes more sense.
I can mention a few places where it comes from. So there's a few sources within lithium-ion batteries where that fluorine can come from. One of them is the binder. PVDF is the acronym. I want to say it's polyvinyl something. I don't remember off the top of my head, but there's some fluorine in there that can break down in the binder. And there's a salt that is added to batteries, LiPF6, which is, I believe it's used to improve like aging behavior and keep the cell better for more cycles, like more cycles of the battery. But that's another source of fluorine as well. And when these fluorine-containing things break down, especially with the high heat that can be available here, HF can be liberated from that. So here's a view of what that looks like from the outside. So we had this deflagration push gas about 70 feet across our lab. And it was enough to dislodge the garage door and also displace a lot of the equipment that we had in that immediate area in front of the garage. On the subject of HF, because I know it's of interest to this audience, if we look at these lasers, so we had them at point blank to the garage, 20 feet and 40 feet. These were tunable diode lasers that were tuned for HF. And they did not register above their detection limits in this test. So while there may be some HF present, at these distances, it was not high. I think the detection limit was about 1 ppm averaged over the width of that driveway, is about maybe 15 or 20 feet. So I don't want to say there's no HF present, but it was not a huge hazard identified in this work. So our third test combined the unventilated commodity fire from the baseline test with the unburned battery gas component of test 2. So we started the event as if something else in the garage ignited. Once the garage was ventilation limited, we introduced thermal runaway in that battery unit similar to test 2 and allowed the event to develop from there. So something I know that I've been taught, that Dan Majikowski likes to teach, is that smoke is fuel. Where you have smoke, that is unburned fuel. And with the addition of this battery gas, you have enhanced flammability here. So I'm going to show this video, and in contrast to the baseline test, the moment the sparks ignite here, you have ignition of the flammable gas and smoke that's being vented around the seams of this door and other leakage points. It's most obvious here from the thermal image. And as the vent was pulled in, that gas came out flaming as well. So this is something to consider when deciding how to intervene or what to be prepared for as how a situation can develop. So our fourth test we did not make entry or ventilation through that garage door, but rather through the access door to the structure. The conditions at the time of these videos that I'll share were from a very similar condition to test 3, both ventilation limited commodity fire and unburned battery gas. And what we found is when we vented the service door, which you can see in this first video, you have to pardon the video quality a little bit. We had some walkie-talkie interference. But now, though there was limited smoke showing around that door to begin with, once it was opened, this plume of smoke and flammable gas and possibly some other toxic components would now be introduced into the structure. And within 40 seconds after this ventilation, the flammable gas layer stirred, there was more air introduced. We had a backdraft occur and push this fireball out of the door, which just shows how rapidly the behavior can occur after a ventilation operation. So after this test program, we were trying to determine if battery involvement wasn't, you can identify it based on cameras, gas meters, things like that. But then the unanswered questions were, what do you do if you do suspect battery involvement? Additionally, to narrow in more on that explosion hazard, how much battery gas is needed to create an explosion hazard, and what is the nature of that explosion hazard? How far can it extend in this setting? And what may you expect? So as I'll remind you from these images on the right, to do this testing safely in our lab, we built this structure out of steel to withstand the pressure, but we wanted to understand what that would be like in typical residential construction. And for that, we conducted the second follow-up project sponsored by the Fire Safety Research Institute and with support from us at UL Solutions. So we went to an outdoor test facility in Western Illinois and built a typical 2-car garage structure. We worked with a contractor who built a lot of this type of home to understand how to build it in a representative fashion. This L shape here was included so that it was structurally the same as if the full house was attached. Our interest here was in focusing on the deflagration and explosion hazard and controlling those variables. So when we have live batteries like we did in that previous test program, we can't control exactly when ignition occurs or exactly how much battery gas is involved. So for this program, we synthesized it. We knew what the major flammable components were and ordered bottles of that gas to control that deflagration hazard size. So we conducted 20 tests like that and 1 test with live batteries. This report is in progress as well, and when it's complete, I'll share this. Both these reports will be public, available likely through our website as well as FSRI's website. So we conducted 3 types of tests in this program. The first was focused on partial volume deflagrations. So these bags you'll see here, and I have a montage of them. So this is creating the worst case gas cloud. So instead of releasing gas unconfined into the garage, if it were to accumulate in a cloud around the battery containing unit, this is the severity that could get. So that was the first scenario we ran. The second scenario we ran said, okay, we know that's the worst case. What's a maybe more realistic case look like? So we released gas unconfined into the room, and I can show you one example of what that looked like. So we had this gas ignition layer proceed down through the room. You can see with those flaming bits at the end, we had some test signs on the wall, is that there's a significant heat there. If you watch also the video on the right, you can see from the thermal imager just how far that hazard is extending from the garage. This is the third test or type of test we did, which we actually used batteries. You'll note this is the same design of energy storage system that we had in our previous test program. The thermal runaway behavior looks quite similar. In this case, the gas did ignite itself, but earlier in the process. So there was only about half the battery involvement at that time. I would love to do this another 100 times to see how many different ignition scenarios we can get, but we were only able to do 1 at this time. This is what that looked like from the outside. So in a more typical construction than what we did for our indoor testing, this is what that gas could look like outside. Some of that characteristic low vapor, but understandably with any wind or particularly bright day, it may be hard to see. So I will share some high level considerations that we developed and then turn it over to Captain Clare and Captain Balcome for their more in-depth experience with this sort of thing.
Alex,
yeah.
what was the gas concentration equivalent to in number of batteries?
For batteries. So we were looking mostly with respect to the gas concentration. There'll be more about this in the report, but we've developed a correlation of basically liters of gas per watt hour of battery, both for NCA chemistry, which is the cobalt containing chemistry, as well as LFP, which is the way it seems many parts of the stationary energy storage industry are tending. So the gas concentrations and quantities per watt hour are a little bit different, but we looked at both of them. And then we also looked with respect to percent LFL, because there are some references in the building codes to not exceed 25% of the LFL in a well-mixed version. So we looked with respect to that as well. We spanned a pretty wide range from like 0.5% of the LFL up to like, I want to say something like 200% of the LFL. We spanned a pretty wide range over this program. So the first one consideration that I want to share is that this low-hanging white vapor may be present. We've seen this in our test programs when only batteries are involved. And you can see this as well from the incident in Surprise, Arizona, where if nothing else is involved except the batteries, there may be this neutrally buoyant, low-hanging white vapor cloud. And you can see that again in this video from our outdoor testing. But what you can also see in this video is that with just a little bit of wind, that warning sign may or may not be available. In Erie, Colorado, certainly there was nothing externally visible. We can get into some of this with much more depth. In the interest of time, I'll describe these in general because you can access this information afterwards, and we'll be having a full report out soon to go in depth here. But as far as size up, we did not find any reliable visual or thermal image that confirmed battery gas involvement. So when there was only batteries, there were some visual indicators, but when there was any other room and contents involved, we did not find any distinct metrics to say, if you see 100 ppm of this, that's batteries, but otherwise it's not. Unfortunately, we didn't find any obvious signatures like that. So with that in mind, we encourage full structural PPE with respiratory protection during size up based on how fast the situation can evolve and change. And additionally, because of this potential for an explosion hazard when batteries are involved, we're discouraging parking the apparatus right in front of that garage door or being close to that garage door if it's not necessary, or other ventilation points, and being mindful of those hazards that can develop. This is reinforced by that incident in Colorado as well. As far as some considerations to account for when determining tactics is, again, this explosion hazard. It begins to develop once the first batteries undergo thermal runaway without burning. And then the size of that hazard is going to increase as more batteries become involved. Many products are being designed to limit propagation to try and keep these events small. But in the event that they don't, or those protections aren't in place, it can continue to expand from there. And this hazard can develop before there are exterior signs. So with that in mind, do not approach the compartment to take portable gas meter measurements if batteries are suspected. We found, based on some of the cross sensitivities in these meters, as well as the inability to distinguish batteries when there's other room and contents involved, it's likely not necessary to put yourself in harm's way to take that measurement. if it can be avoided or if other things can be done instead. And additionally, just being prepared with hose lines and all of the other operations before ventilation or entry, because as we've seen, some of these events can really develop quite quickly, and as prepared as you can be, the better. I'll end with just a couple reality checks and then turn it over to the other presentations that I'm interested to see as well. So the first is that where you have the potential for significant thermal runaway and a significant amount of battery gas, that's where these hazards can develop. This could be e-mobility, this may be electric vehicles, energy storage, or just collections where you have a large amount of like battery powered tools stored, for example. We are actively developing a standard right now for battery storage cabinets, both for fire service use and commercial use, where you could store, say, drill batteries or e-bike batteries and contain those hazards, sort of like a flammable liquids cabinet. That's in the works now because we've identified that that's a potential hazard. And then the other reality check I'll share is from FSRI. Many of you, I imagine, have seen this video already, but they have done a series of e-scooter demonstrations, as well as some sprinklered tests. And this one is an unsprinklered event in the living room. And what you'll see is after overcharge, there was no previous external signs, but once the battery began to fail, you see this gas cloud develop quite quickly. It ignites, it blew out the windows of the living room as well as the bedrooms down the hall where the doors had been opened. So this, again, is to reinforce how fast these events can develop, as well as the hazard of ventilation points like a garage door or like these windows.
Alex, a couple of questions. When
Sure.
in-home storage stations or cells are present, is there a requirement for signage?
Nationally, there is not a requirement for signage, but I know some jurisdictions are starting to do that. At Monterey Bay, there's a jurisdiction in California, which is working towards signage for energy storage systems, as well as when you have electric vehicle charging stations in your house, to potentially warn of the contents. There's some resistance to that idea by home builders and stuff, because they and some, building owners don't necessarily want all this signage, but there is a trend towards it in some locations, and there could definitely be a benefit of it. So I wouldn't rely on that as the only indicator, because then there's like the DIY and some whatever else people do that they won't install signage for. But the other warnings that you may have in addition to that type of signage would be like if you see an electric vehicle, there's a good chance that there's energy storage as well. If you see solar panels, those are often installed with an energy storage component. So there may be other context clues of battery involvement.
Do you know if the battery manufacturers are exploring options either in chemical composition or mitigation of thermal runaway?
Yes. Yes to both. So there's a lot of progress being made from the commercial side to reduce propagation and the extent of battery involvement. So some of this is by battery chemistry, and some of this is either by passive means of protection, maybe some active means of protection. I think in a residential setting, it's more likely to just be passive. So barrier materials or spacing between cells, as well as battery management design. On the commercial side, more larger energy storage systems, there is a trend to consider some active systems as well, either active suppression with water or other agents, or an active ignition of the gas to reduce the explosion hazard. there's a few different philosophies out there, but based on the last several years of incidents, both in the field and increased testing requirements, there's definitely this arc towards reduced propagation that's happening.
Have you done similar testing in industrial or commercial arena, in the industrial or commercial arena?
Yes. So there's a lot of testing that we do at UL for commercial products, but we have done a public-facing research project in 2020 that looked at containerized systems. That research report is available, and I'll throw a link to that in the chat. There's a full research report on that. So we had a containerized system, and we looked at a few different means of suppression, as well as handheld meter readings and things like that for that type of system.
What are symptoms of impending battery failure?
Okay, so it's going to look a little different depending on how the battery's failing. There may be a venting of electrolyte. So the cells, many types of cells are designed with a vent. So when the battery begins to fail and you have increasing vapors due to the chemical reactions inside that cell, they will vent. So there are some technologies looking at detection of that. So like looking for VOCs, volatile organic compounds, or hydrogen, CO, some of the other precursors that may be in gas signature. There are also electrical signatures that may be present. Now, those are likely things that only the battery management system knows. That wouldn't necessarily be obvious to someone, just approaching outside the product. Some systems, I don't know if it would happen in the residential space or not. Some of those systems communicate to some, central database, like a SCADA center or something. So there may be some warnings in that regard. The other warning that I could think of is sometimes there's like a popping sound when those vents operate, or there may be a funky smell, which I know is a difficult thing to rely on. And I certainly wouldn't encourage anyone to remove respiratory protection to smell for batteries. But it's something like a homeowner may notice, sort of this solvent chemical type of a smell.
Jack, I think the other two you've handled, or should we address any of those other questions in the chat?
I can just do it verbally. So the one question was about someone who had, the crew had taken a battery that had been dropped off at the firehouse, and they were asking what to do about that. I put in the chat that there is a vendor down in Lancaster, just south of Columbus here, that is a lithium-ion battery recycling place, a facility.
Mm-hmm.
They may take it. I don't know if they do those. There may be a cost to it, but the transport of that, with it being unstable, may require a hazmat hauler, a licensed hauler to do that. And that really does kind of then dovetail into Chief Yetter's question about once they've either exploded or caught fire, what's the EPA state about cleanup? And I think that Captain Balcome can talk about that, what they're doing at FDNY and in New York State. I know that out in LA, where they've been actually picking up the entire car and putting it in a 20 cubic yard dumpster and filling it up with water, and using that as an overpack to haul it to the scrap yard. The EPA is saying, well, now you've dumped that into 10,000 gallons of water, and now you have a hydrofluoric acid solution, whatever strength that might be, and no, you can't just dump that water. So that's creating some downstream problems. Not to mention the fact that then the car dries out 2 or 3 weeks later, and the battery continues to go into thermal runaway and catches fire again. So I know that in New York, they've been using a product called Cell Block, and basically the smaller batteries, not car batteries, but micro mobility devices, things like that. They're overpacking in this material called Cell Block, and then having either their sanitation people take care of it or a contract hazmat hauler. And so Captain Balcome can go into that a little more. I've not heard of any answers for here in Ohio specifically.
Do you want to address these other questions or introduce your next speaker?
Let's see. No, there's no recommendations for storage of multiple vehicles in underground garages. Vehicle battery bulk storage and rack storage. How effective is ESFR sprinkler systems in dealing with thermal runaway event? That kind of gets into the same issues that we're having with a single car fire or anything else. And that is, are you actually getting water on the battery itself? So, you know, Evan can talk about that a little bit, but you know, a Tesla, the outside battery case is titanium. Most of the other manufacturers, at least the tops, are either plastic or aluminum, which tend to burn off. But then you've got the floor pan of the car itself, so it's almost two different fires. You've got the room and contents, right? The interior of the car that's on fire, and then the battery is a separate event almost. And I think that's where we're starting to hear. I'm going to steal some of Evan's thunder a little bit. You know, 30 to 40,000 gallons of water on a car fire. Well, if you're not getting it actually into the battery and you're flowing at 250 gallons a minute, that's why. You know, so some of that comes into tactics and how are you applying the water. If you can get it directly on it, then that does tend to, and Alex will probably weigh in on this too. If you're getting actual direct water into the cells, then you're cooling that thermal runaway while you've got that overpacked in water essentially. But we've all seen the scenes where they'll put up half a dozen aerial platforms and they're pouring 1 million gallons of water in a defensive posture onto a large building. And while that roof is still intact, it's doing its job and there's no water getting on the fire. So you're really in the same situation here. You can fill that car up with water, but if the floor pan has not been perforated as is the top of the battery case, then you're not getting water actually into the cells. And so understanding how cars are manufactured or buses or whatever, and how to disassemble that or how to get the water in there, that is a big part of this challenge in developing our tactics. Alex, you want to weigh in on that at all, or Evan?
I don't have much to add there, except there is, certainly a challenge of getting water where it needs to be to do the cooling. And just to plug that FSRI is embarking on a multi-year project looking at EVs and response tactics. We don't have anything meaningful to share out of that yet, but as it becomes available, we'll certainly be transparent in sharing all of that.
Okay, good. Well, thanks, Alex. I appreciate your time and insight on all of that. With that, I'm going to go ahead and introduce Captain Evan Balcome and let him get started on his presentation, and then we'll handle the rest of the questions in the chat, either via chat or after Evan's presentation.
Excellent. All right, Jack, can you hear me?
Yeah, I can hear you just fine, and I can see your PowerPoint up there now.
Okay. All right. Right here. Okay, excellent. Just want to introduce myself real quick. Captain Evan Balcome, New York City Fire Department. I've been working at the auto extrication unit since 2020, and considerations around EVs. This is about a 2-hour presentation. I'm going to try to cut it down to 20 minutes, so I might skip around to a few different things. Any complaints on that, you can send them to my email at hotjacksmith@aol.com. So first, I just want to set some expectations. I'm not a chemist. I'm not an engineer. I think Alex did a great job before me. I'm just the captain in the New York City Fire Department. We're looking at considerations around electric vehicles. It's my first caveat. Second one is EVs. We're going to talk about all the negatives on EVs for the next 20 minutes. I'm not saying I'm out or this is a bad technology, just saying that we have to talk about the negatives. Really, electric vehicles are 11 times less likely to catch fire than your classic internal combustion engine vehicle. So even though we're just going to focus on the negatives, remember, this is still an up-and-coming technology. And even if, as firefighters, we want to complain about everything and say we don't like it, it's still here. We still have to deal with it. So electric vehicles, they're different. Our paradigm that we built off the last 120 years was built around internal combustion engines. So everything, the way we dealt with it, what we knew, a V6, a problem with a V6 or a V8, a large truck motor, a diesel motor, we're going to have a ton of different types of electric vehicles, whether it's a hybrid, which have been on the road, we have some past 20 years, but really since the introduction of the Prius, we've been dealing with these without many incidents. Plug-in electrics, full electrics, and then battery types. I think we did this slide, we prepared this slide a year and a half ago, and already our considerations on the batteries have changed. So this really is an evolving challenge. Of the challenges for the fire service, what we like to think about and focus on are identification. We need to be able to identify the vehicle. We have high voltage, unintentional movement, delayed ignition and reignition, and extinguishment. I'm going to breeze through these, and a lot of this presentation works better. I kind of give a quick idea or overview on this, and then we go back and touch it through questions. So if you have a question, wait a slide or two. The answer might come up, and if it doesn't, then we'll discuss it afterwards. And I like the back and forth because how I work in New York City might not work where you are. So upward trend, we know this is increasing. The problems we've seen are only going to grow, as well as the technology is changing very rapidly. The adoption of this early on was a little slow, but now we see a very fast increase. So identification. If you pull up to a vehicle, I think most of us think we have an internal combustion engine vehicle and we're going to operate under that classic paradigm. So how do we figure out what type of vehicle we're working with? Is it the badging on the outside of that vehicle? Are we looking for the exhaust? Are we looking at the front? We see it doesn't have an open grille. EVs don't need the airflow coming through the grille. They usually have that front trunk that we were going to call the frunk, and most people use as a cooler. Is this, is it just basic knowledge? Do I know that a Tesla is only going to be an EV? So is it firefighter knowledge that's going to tell us that this is an electric vehicle? Is it the noise? Because if I hear a motor running and then the motor turns off, does that mean the vehicle is off? Does that mean I have a plug-in hybrid? All these things we have to take into consideration. And then charging port. If I open that gas lid, the gas filler lid, and I see a charging point, that's usually a good indication that I'm dealing with an electric vehicle. So those clues we're looking for, that badge could be, a 1-inch by 3-inch hybrid sticker that has a little piece of blue on it, or on the Volkswagen Golf, do I see that little E that tells me this is an electric Golf? We're looking for these very tiny little clues, and how are we going to solve this in the future is going to be different in every state. So possible solutions that we've thought of and that we've worked with. I am on the J2990 First Responders Task Force for electric vehicles. I also took part in the UNGTR EV25 meeting, and all these ideas have come up, but some don't work throughout the United States, which is tough because we're pretty much 50 different states that operate completely differently. So if I come up with a great solution in New York, will Ohio or California adopt that? Like a marking on a license plate, we've identified there's about a 1.5-inch square in the 4 corners of the license plate that we can put something. Now, I was just complaining about the size of the E on the e-Golf. If I put something on a license plate that's 1.5 inches, are we really going to see that? Is that going to, identify this as an electric vehicle for everybody? Do we put colors? It seems right now blue is the color of that manufacturers like for EVs. Stickers. Can I put a sticker on a private car? We like to do it here in New York. You get an E-pass or, the electric pass that you're clean energy, and you might get into that HOV lane. But is that working across the country? We said fuel door stickers. So if you pop that fuel door open, is it going to tell you what type of car we have? Physical identifiers. We've looked at putting maybe a shape or something on the car to tell us. These are all future ideas. Bluetooth signals is one I personally like, because we're operating with an iPad on every rig, and we're getting smarter and smarter with our response while using technology, but you can never rely on technology. OnStar system or telemetry system, as we respond, are they going to tell us in this 911 call you're responding to an electric vehicle? And can they give us the information that how much charge that vehicle battery has? And QR codes. We already have one manufacturer using QR codes to give schematics for these vehicles as we're responding. You open the fuel door, you look on inside the driver's side door, and there's a QR code that brings you right to that manufacturer's website that has a full schematic of the vehicle and tells you the dangers. So rescue data sheets. This is actually how I got into my considerations with electric vehicles. I was teaching at the Randall Island Extrication Center, teaching extrication every single day. And we had a firefighter come in and said, "What are you guys doing with the rescue data sheets?" And for what we thought we were experts on extrication, there was a great resource out there being used that we weren't aware of. So I really like to push the rescue data sheets. They are not mandatory for every manufacturer to produce. Other countries, Europe, Australia, they are using these rescue data sheets. And to put your car on and get a 5-star rating, the manufacturer has to produce a rescue data sheet. So at first they were called emergency response guides, ERGs. Now an ERG is longer. If you look at older guides, your ERG could be long or short. The QRG, 4 pages, concise, gives you, really good document that you can find a schematic, what to do in case of fire. And while this might not seem as relevant right now, as battery technology moves forward and we get more types of batteries and we learn specific ways to put out, a nickel metal battery reacts differently than a lithium-ion battery. We're going to want to use this, and when we get to like solid state batteries, maybe it has a completely different operational procedure. And that's where I'd really want to reference the ERG or QRG. And the way we do it has yet to be seen. So ERGs, QRGs, it's a comprehensive list. This is the recommended format for an ERG. ISO 17840 document should follow these steps. It should be color-coded, and it should have everything listed in this manner, so it's quick for a firefighter. And this is a different consideration in New York City compared to where you are. I could show up at a first response, a call for an order of gas, and I have 35 guys there operating, and I have the availability of somebody to look at this ERG where you may not. So it's a consideration. So extrication info. If I'm looking to cut into this vehicle, that ERG is going to give me a lot of data. So when I show up to an extrication incident, I want to pull this up. It's going to tell me, maybe I have a first responder loop that can shut down power. And now shut down power isolation is different from power removal. We have to keep that in mind. And also when I'm cutting into a vehicle, I want to know the location of those high voltage cables. So right now, the best way for most people to access the ERGs is the NFPA website. They have a catalog. It is by far not complete. Many manufacturers stopped submitting ERGs in 2019. We're trying to update this or work. The FDNY has actually created a catalog where it's in beta testing right now in the 4-8 Battalion. And once we make this a functional app, we want to share it nationally. And that would have every ERG and QRG available for every vehicle in the US. So electrical hazard. I'm going to open that ERG up and I'm going to find my electrical hazard. So what is my electrical hazard? There is a potentially fatal electrical hazard in this vehicle that is usually contained within that battery compartment and along the high voltage cables that run throughout the vehicle. The high voltage cables are going to be, that bright orange color, and we know not to cut the bright orange. But when I get to maybe the DC to DC inverter or the high voltage motor that drives the vehicle, those aren't going to be labeled. Those aren't going to be bright orange. You might just have something that looks like a motor, and if you poke a tool in there, you're going to have a bad day. So power removal. When do we do this? Extrication. If we have fire, what are the tools and considerations? I'm going to try to touch on these over the next few slides. If I'm going too fast, you have a question, please, Chief, just hop in and let me know. So power removal, we have that high voltage power removal loop, and that is not actually high voltage. That's a low voltage loop. So that's driven off the battery, and that is going to charge or drive a circuit of some sort. Every manufacturer has this operate differently. If you cut that and you cut 12-volt power, that is supposed to isolate all high voltage power to the battery pack. Now, if there was an incident, you may have had an arc in this car, and that may have fused that high voltage circuit. It may have fused it open or closed, however you want to look at it. And now we still have high voltage leaving the battery pack. So we cannot rely on these. So we had that loop we call the first responder loop, but we see in the picture in the bottom corner, that is a Volkswagen plug that they use instead of a loop. Better picture here. So this green plug, if I unplug that, that removes 12-volt power, and that will open that circuit. So we no longer have high voltage power coming out of the battery. Where if I have that first responder loop, that orange little cable, and that tag we're going to see hanging off of it has a firefighter helmet and a little book. And that's indicating that that is our first responder loop that will shut or isolate high voltage power. So if I'm going to perform an extrication or I show up at a vehicle incident, I'm not sure what's going on, I want to look where this is. For me, again, the best place to find this is going to be that ERG. There are manufacturers that produce vehicles that do not have a first responder loop. Do I want to waste my time telling a firefighter to look around this vehicle and look for something that's not there? Again, we're going to reference that ERG or QRG. One big consideration here, there were older QRGs that said to use the manual service disconnect. So that manual service disconnect in the FDNY, in my opinion, we don't operate. We do not touch that. It says to wear appropriate PPE. To me, appropriate PPE is firefighting gear. But when you're operating a manual service disconnect, appropriate PPE is lineman's gloves and electrical protective equipment. So if we're going to have an arc or a problem go when we're operating on a vehicle, it's going to be when we pull that. You may have an arc when we pull that manual service disconnect. So pulling a fuse, which is also, and you look at the bottom two pictures, the ERGs may reference these fuses. So if you cannot get, you had a front end collision and you can't get to the first responder loop, and there's no first responder loop located in the back C post that some manufacturers have placed, they may tell you to go to these fuses and pull the fuse. That will also isolate high voltage power. So any orange, anywhere, we're going from batteries, you can see the orange cables here. Any of these orange cables that are throughout this vehicle, and some older models had them in the passenger A post. So if we had to do a dashboard displacement, we might have cut right through an orange cable. So if you don't have an ERG or a schematic, we teach peel and peek. So we're going to peel back that fender. I'm going to look at anything before I cut it and try to get my best case scenario. I'm going to cut through that A post because I have to get the person out. If you look on YouTube, there are videos of people cutting through high voltage cables while they're charged and nothing happens, but we don't operate under nothing happened one time. It's not safe to cut through these. Do not cut through orange cables. So unexpected movement. Well, my main consideration when we started looking at electric vehicles was electrocution. We haven't found a documented case of a first responder or a responder being injured by electrocution on an EV. But we have found dozens and dozens of incidents of first responders and civilians being injured by unexpected movement. We had a FDNY member starting to enter a BMW. The car was silent. They didn't understand that it was a plug-in hybrid. They just didn't know because the badging was very poor. The car jumped forward with the high torque. It was able to jump forward and it crushed that member's leg, and they may not be able to return to the job. So this is where our paradigm has to change. We were used to internal combustion engines. If I walked up to a car and it was making noise, I was worried about it moving. Now, if I walk up to a car and it's silent, I have to change my paradigm. I have to change my thought process that there's still a danger in this vehicle. Even if it looks like an older vehicle, it may jump forward with tremendous force. And the torque is so high, we've placed chocks on EV tires, and that EV just jumps right over it because it has low end torque right away. So what can we do about this? Few options. We've started to work with the manufacturer, the rescue plug. It's an interesting device. Most of the time we've seen it work. We talked to some Australian firefighters that tested it, and they had one of the wheels still moving on the vehicle, and the rescue plug didn't work. For most incidents, it did provide an added layer of protection. We still followed traditional SOPs, either chocking the vehicle or rig placement. If we have a non-plug-in hybrid, this isn't going to work. We're going to need that plug. But we also tested a dead end plug where we just cut a charger plug. We placed it in that charger, and different manufacturers have a physical indicator. So the standard is written, if this car is on charge, the car has to be put either in park or somehow taken out of drive. So some vehicles go into neutral. So you put this plug in, it kicks the vehicle to neutral, puts the brake on, and when you pull the plug out, the vehicle doesn't go back to drive. The driver would have to physically hit the drive button and put it back into drive. So non-fire related emergencies, we consider now apparatus placement. If I pull up and I have a silent vehicle and they're at a stoplight, this could be a seizure, a drug overdose. I want to think about where I'm putting my rig, especially if this is an EV. That person might wake up and we had a silent vehicle, and now they wake up and they hit the gas and they take off. So I could get a rig right in front of that vehicle and a rig behind it. But while we're doing this, we also have to consider firefighter safety, our normal SOPs for traffic and possible injury to firefighters, but it's just a consideration. So a lot of these are just considerations. They're ideas on what we've seen work, and what you can do in your area. And we'd love to have this conversation afterwards on what we've actually implemented in our procedures. All right. So we are seeing more EV fires. They always make the news. Every EV fire you see on the news, just remember every 3 minutes there's an internal combustion engine fire, and that's not on the news. So why? Probably because we know how to put those out. Those are simple incidents. We know how to control gas. We know how to deal with that. That's a paradigm we've gotten over 120 years. But if somebody told you in 1905 that you were going to put 40 gallons of gasoline in your garage to your house, you'd probably say you're crazy. So now we're kind of dealing with the same beginning of that with EVs. So different fires, is it the car or is it the battery? If it's the battery, what type of battery is it? And as we get more batteries, how do we deal with them? Is this NIMH where it's a little less volatile, or is it different battery designs themselves? Because there's one manufacturer listed here, and between those two different battery designs, one burns out. The entire vehicle battery will burn completely out, let's say within an hour and a half, where the other one, the modules are a little further apart. So you might get 3 or 4 modules to completely burn, then it would go out, and then 6 hours later, it completely burns a whole nother set of modules. And then we still have, it's 3 rows of modules that will go over time. So can we commit an engine to sitting there and letting this thing burn for 20 hours? And that's going to be model to model. And where you are you in a city, or are you next to a farm where you can let this burn? And lastly, charging station fires. That adds another layer of danger for firefighters. First, we have our car fire. Car fire, battery not involved. What do? We do what we're good at. Put the wet stuff on the hot stuff, right? Take the windows. If we have gas buildup in this car, we have a possibly explosive environment. Put the car fire out. And now, as people keep talking about New York City being very involved in this, I just like to say this. Out of 8 million people in New York City, numerous electric vehicles, we still have yet to have one electric vehicle incident where the battery was involved. So the 3 we know of, one, somebody poured a flammable liquid on the hood of the car, lit it on fire. The other were interior car fires. Not sure how they started, but the battery is not involved. So second, what we've seen from the research, battery fire, we want to cool those cells down. Foam, is foam shown to work? Not really. Full submersion, is that an option? If you have the budget for it and you're willing to deal with the problems that come after you now have water intrusion to the battery pack, it's a consideration. But really what we've seen work the best, just cool it down. Whether we're cooling it down from the outside, I like to say this is a fire in between 2 frying pans. So you put 2 frying pans around your fire, and that fire doesn't need a source of oxygen. How do we put that out? Can you really put it out from the outside of the frying pans? And then vehicle chargers, there's so many considerations here. If it is past the charging post and it's in the cabinet, that is a service provider issue. We're going to have our electric service provider show up. So rescue data sheets, older rescue data sheets, there are 2 right here, and they show you vents for the battery. So if I looked at this rescue data sheet and I had a smoking battery and we were able to angle water to get in either the trunk of the Acura RLX and I could put water in there, that's going to flood the battery pack. Or you can see this older Accord hybrid on that ERG. It told you there was a vent under the rear seat that we can get water in and get access to that battery pack. Other unique hazards, right? We have solar panels. I'm sure you're dealing with this as well. So you have solar panels. Now do we have solar panels with a battery backup? Are we going to cover the solar panel with pretty much our Flex Seal spray or a blanket? What are we going to do to mitigate this? Another consideration. So what are our tools that we can use to deal with this? First, every engine company that shows up can put water from a hand line on the battery. Everybody can do it. It's adjustable. We can move it over. It doesn't take a lot of manpower. It doesn't take a lot of time. The problem, we have members operating near that fire. And like we said before, if you're just dumping water on this, we've heard of 30,000 gallons put on this just to cool that outside battery pack down, and how long that manpower has to be there with SCBAs on. I also like to put water inside the car because as the chief mentioned before, we may have a very thick, a 5mm battery case in the bottom, and the top may be 1mm, or it could be thin, it could be fiberglass. Most I've heard are still aluminum or metal, and there are new designs where they're using a different type of aluminum on the bottom of the battery pan. But new considerations as new models come out. Fire blanket, we've used this, we've seen this used. This will not put the fire out, but can mitigate the risk because we are stopping some of the fuel that's going in there. So this might be used for exposures. You might cover the 2 cars next to it and tow this car out. We might cover this car up real quick while we get, a line in place or a large caliber stream. Definitely a good consideration. We like it, but now we also have added problems of putting this back on the rig. What are the contaminants in that blanket that we're supposed to fold back up, put back on the fire truck, bring back to the station, and put contaminants with our members? Unmanned large caliber streams, how close we can get this, the manpower. If you have the water, this is a great consideration. We have different types of LCSs. Some of these can move around. We might set this up in a parking garage. So I might get a hand line really quick and I might put this down and that car is going to keep burning. But hopefully I stop this from extending to the parking garage, the structure, or other vehicles around it. And then undercar nozzles. So we don't have pictures of the in-car nozzles. There are new nozzles, very rudimentary tool that we break through, the top, and those have actually shown to work pretty well. We were in Norway, and the Europeans are using this in-car nozzle where they pretty much drive a spike through the top of the battery. Due to the fact that it's thinner, they flow water, and they've had good results with that. Undercar nozzles, low water flow. This is about 70 gallons per minute. There are many different models. I like the turtle, which is not pictured here. There's a turtle nozzle that goes underneath, and it can put out a ton of water. It's a little more sturdy than this, but if you're looking at water flow, this is the toxic suppression nozzle. Again, there are many of these. Which one you like, it's up to you. And then undercar penetrating nozzles, mixed reviews on this. If you're not hitting the right area, this could be difficult. It is complicated to use, and the cost is high. Again, it's a consideration for me. This isn't a winner, but in future, if we have planning on where this is going, if manufacturers are part of this discussion, this may be a good option, but right now I don't think it's quite there. And full submersion. So if you can afford a crane and something to pick this car up, put it in there and fill it up, but now we're adding to the response afterwards with our hazmat, because that water is now going to be considered a hazardous material, and we're going to have to do something with that. So logistics, cost, how many of these do you have? In New York City, we'd have to buy at least 5 of these. You can go with as simple as a dumpster. You get, a 20-yard dumpster and a winch on the front. You just pull that vehicle in and you put water in it. That might mitigate the hazard. So post-operational considerations, what are we doing with this vehicle? The biggest takeaway that we've found is the planning before you do it. We're talking to LA County and LA City. They're having tow truck drivers show up and refuse to tow electric vehicles because they could lose their entire fire truck if this thing catches back on fire. So we need to find the recyclers. We need to find an authorized tow truck, and we need to have a plan. Are we going to have an engine company file this tow truck back to the tow yard? And when the tow yard puts it down, we recommend 50 feet from anything else. Or are you going to build up? I think we were in Detroit, and they showed us they had built concrete barriers in between vehicles. So if it does catch on fire, it's not going to spread around the parking lot. So that consideration before we have the fire is really, it's planning for post-operational. The planning that goes on beforehand makes a difference here. And non-intervention, my least favorite, because how often do firefighters want to show up and do nothing? If we have a fully involved electric vehicle and it's going to burn out, this may be your best consideration. But where is this? Are we in a city center? Are we on the BQE that's going to slow down, 1 million commuters every morning? Is that going to be my call here? I don't know. That's up to you. But some people are falling back on just letting it burn out. Non-intervention, letting it burn out, closing the road down, closing the space down, letting it go. Enclosed underground parking garages. This is one of our larger fears. So one of the bigger problems here is that parking garage sprinkler systems are not equipped to keep up with vehicles right now that aren't internal combustion engine vehicles. The sprinkler systems can't keep up with the amount of plastics that are in vehicles already. When you consider foam, seats, plastics, they just can't keep up. Now, there were 3 or 4 students in Norway. We attended the battery symposium, Rise and 5 last month. I can't tell you how many people were saying that the heat release, the total heat release, and even peak heat release from an electric vehicle is less than an internal combustion engine. That's not what I would have expected. We still haven't seen the data to back that up, but we still have the consideration that it's going to be a longer operation. So the smoke that comes out, the possible explosion hazard, those are still problems. One of my considerations there is going to venting. So do I want to park that electric vehicle right at the mouth of the garage where I can charge it? I can charge it right there, and if there's a problem, I can get it out, and the smoke is hopefully going to come out. Or is that fire now going to cause a bigger problem on the outside of the garage? And if I'm at winter, that electric vehicle being cold, you might lose 40 to 50% of range or capacity. So the owner is not going to want their vehicle there. And here's something we're dealing with in New York City. So we have a high-rise building that's over 50 stories high, and they have an underground automated parking garage. And now as they integrate charging into that parking garage with these vehicles, this is a new hazard because we don't have good access to these vehicles. Now, I don't like these parking garages already with internal combustion engine cars because this is going to be a very complicated operation. We're looking into developing good SOPs for this, but this is not easy. So right now, there's ANCAP and Euro NCAP. These are the rescue apps that are used in Europe to get those ERGs. That one up top is pictured, and the bottom one is the FDNY app. We're hoping to have up and running in the next few months and be able to share that nationally. So our best solution, share, usually the conversations I have after a presentation is I get the most information and we can share more in the conversation. But I hope I've covered everything there, and that's all I got.
Evan, does the water runoff from extinguishing a lithium battery fire constitute a hazard waste that must be disposed of properly?
For us, it does not. If it's possible, if you wanted to try to, I don't know how you do that with 30 or 40,000 gallons. If you can capture something, and also depending on how involved it is your water running into the battery pack, or are we just cooling the outside of the battery pack? So right now, if we had an electric vehicle fire in New York City and we had an undercar nozzle, we are not containing that water. I don't know the regulations on that, just the considerations we have so far. We are not able to contain every bit of water we put on, even a structure fire that we know has hazardous waste in it.
Hunter Clare is saying in Arizona, we had testing on water runoff and didn't find it to be much worse than the runoff from a house or commercial fire. But the water, when it has been submerged for longer periods, had higher levels of metals.
Excellent. That sounds like a great answer. Thanks, Hunter.
All right, well, Thanks, Evan. I appreciate your time and insight on all that. That's been a huge help. Can you hang out for a little while and we'll do the panel discussion after Hunter's presentation? With
Absolutely.
that, actually, while Hunter gets ready to get his PowerPoint up, I'm going to put this QR code back up. So you guys, if you came in late, if you can see that, Andy, do you see the QR code?
Yes, yes, it is showing.
Okay, all right. So for those of you that came in late, that QR code will take you to a web form that you can get a couple hours of Con Ed for, or at the very beginning of the chat, I also put this web OFA email in there if you don't have a phone handy to be able to use the QR code. And again, when we get ready to do the panel discussion, I'll put that up again. So with that, I will go ahead and introduce Captain Hunter Clare from Peoria, Arizona, and turn it over to him for his presentation.
All right, can you hear me first off? And then I'll try to see if I can get my screen going here.
Yes, yeah, we can hear you and see you.
Sure. Awesome. Can you see the screen?
Yes, we
Yes.
can.
Yep.
Sweet. All right. Well, I can't see any of you anymore, just like our other presenters. So now you just stare at your own screen and hope you don't do too many dumb things while you're on camera. So keep me in line there. Anywho, my name's Hunter Clare. I'm a captain hazmat paramedic with the Peoria Fire Medical Department over in Arizona, not on your guys' side of the country. Just so you guys know, we're about to hit our beautiful 112-degree temperatures this weekend, so that should be fun. Stick your head in an oven and welcome to some of the other things that we have going on with batteries and the extreme heat storage that's coming on out here. I've been with our organization. I hit my 20 here actually in the next couple months, so that'll be a pretty cool opportunity with the city there. I've been on the hazmat team since 2007 when our hazmat team came online, and essentially I've been teaching with the consortium since then. This is again, just like everybody else, we're trying to jam some of these things down. I always start the thank yous in the very beginning because I generally tend to forget because you start answering questions and you forget. But you know, all the departments here in the Valley, surprised who we were with on our incident back in 2019. My own department, our CAR 957s, which are part of our consortium set up, the whole Phoenix area, the UL FSRI team, and Alex was on today. She was super gracious when we came back there. I was lucky enough to be on that testing panel. And I think we all got to nerd out a little bit from the fireside that we were all there, which was really awesome because we were all stoked, hoping what was going to happen was going to happen. And we had some industry people there, and they, I think, were blown away when the building actually popped the way it did. And I think all of us were like super excited because we were really hoping it was going to do that. And we were talking about that was the potential that was going to be. And then, you know, sometimes if you build something up and then it doesn't do it, everybody's disappointed. But Alex and her team there, along with Adam and his team and Kerber overseeing a lot of those different areas, they have a great team back there. And a lot of this stuff is not possible, you know, as some of the testing that they've done for New York and Evan's team up there is, it's not possible unless we have these industry experts come in and be willing to step up alongside the fire department, because our voices isolated a lot of the time to our area, and we can get tied in with these groups, these large testings, and have this backing. It really affords us to have a more universal voice across the country. And when you get experts from all the levels dealing with a lot of our different things, it puts us in a better situation. And then Sean DeCrane, who was with UL prior to moving over to the IFF and is now my boss under that stuff with the IFF, were there. But again, Hunter Clare, local 493 in Peoria, Arizona there. And I'm going to talk today about our incident on April 19th, 2019 on a battery energy storage system out there. Our system's a little bit different here in the Valley, considering a lot of the country is our central area here. We dispatch 29 different fire departments. It's all on an automatic aid system. We all go to the same exact academy. So there's 5 accredited academies. They all teach the same exact curriculum that we go around. Most of our units, from rescue rescues, or from our ambulances to our hazmat units, engines, ladders, technical rescue stuff, battalion rides. They're usually about 90 to 95% similar. So if I was to come into your city and one of your trucks was sitting there and I'm pulling off second side, second unit on scene, I know where generally everything is. So that makes us a little unique. So we have one huge Valley Metro department in there, and closest unit goes. So when you call 911, they ping all of us. And if, a Peoria truck is out, but a Sun City truck is the closest, they will respond to your emergency, whether it's an EMS or a fire call. Also here in the Valley, we take care of all the medical stuff too. So we're busy in those areas coming across that. But on that day, this was our APS building that we came into. This is it beforehand. And give a little bit more background on the facility when it comes in. This was a 2 megawatt facility. The crazy thing to think about, and I don't know if you guys can see this, but see the concrete slab that's sitting on right there? That was actually the only thing that was permitted at the time. So city of Surprise didn't even totally understand that this was going on and into place. It was up against one of their transmission stations that was in there. And ultimately, like I said, being 112 degrees this weekend coming in, you know how much sun we have here. We don't really know what rain is. So we don't drive well in it, right? But sun we deal a lot with. And in the Southwest United States, you can see a lot of our solar farms coming out there, and they're trying to find out ways to, help the grid, not only in our states and the draws that are going on, but our neighboring states. And we definitely saw that in Texas when the grid froze and the crazy stuff that came out of that. And I think Evan can even talk to more of that, when they reverse engineered the cars to be generators when the grid failed. So, they definitely are using the Southwest United States to try to help the infrastructure of it. And we are very big proponents of that. So we aren't anti these things. I do have my timer going, so I'll try to keep it as close to 20 minutes as I can for you, Jack. But this facility, when you kind of look at it, it looks big here on the screen, I think. But ultimately, if you think that this building was about the size of a Connex box, standard Connex box, maybe just a little bit bigger. And I think the first thing that you notice when you look at that is we all know what a large Connex box is. There's 4 AC units sitting right on that front side. So again, if you're in here in Arizona and you had a building that was that small and you had 4 AC units, they're trying to dissipate a lot of heat. Well, there was 4 matching units also on the backside. So that was something that came into play on trying to get rid of that heat, keep the area inside cool, even in our temperatures there. Along with this building, that we did not know was permitted in those areas, was it had some sister sites that were tied in and opened and just loved. They all have been shut down. APS has kind of gotten out of this, and they're going to third party it moving on since these incidents. But at the end of the day, the APS people and McMicken people that did show up on the scene were very nice, friendly. They were trying to work with us. However, one of the big things that we found out coming out of it is the people that you think as your SMEs, your subject matter experts, right? And the people that you can go to, what we found out on this is they don't generally in these incidents know more than us. They try to be helpful. They're there, but they do not have a plan. Their mitigation plan is to call 911, and we're there to take care of it for these hazards that they didn't think were going to fail. So on this day, it kicked out. I'll give you kind of some background. That's the other stuff that's coming in, but nothing big there. All right, this is kind of the rough time frame so you guys can see on the incident. The incident actually happened at 16:54, and literally 1 minute after it went off, they had a Novak 1230 system. And for those of you that aren't familiar with a Novak system, it's very similar to the old Halon style systems. And actually on the day of the incident, the people that were there and the people I was on the phone with were actually telling us it was a Halon system. So that actually matched up with kind of some of the cloud that we were seeing, because that's what Halon systems have done generally, right? It's a fire knocking out system. It's not a heat reduction system. You get what I mean? A fire suppression system, not a heat reduction system. And that's kind of one of the things that comes up when you're dealing with batteries, is if we can't cool them, they can continue to go into runaway. And the FSRI UL testing that they had on, I mean, if you can go to their website, they have phenomenal stuff there that will help you, emphasize that stuff to your members going on. But that went back. It went off. So they got a reading that they had a battery issue inside one of their systems. The alert went off at the remote station. They had an activation of the Novak 1230 system, and that knocked out all communication with the inside. The great thing about that is, for the rest of the time, nobody knew what was going on. The sad thing is that not until almost an hour later did 911 get contacted? And it was not by the company. It was actually by a passerby that saw what she called smoke in the desert and thought that there was a brush fire and called in a check fire call at the location. So we never were contacted by the company and couldn't figure out how responding officials showed up to the scene so fast, since they had never talked with us until they magically showed up. So that was a little a lapse in the area going on. So as an overhead view, this screen right here just tries to give you an idea of some of the units. The initial unit that kicked out was actually Fire Station 304, which is located up there towards 303. If any of you have had the pleasure of being here in Arizona, this is basically on about 163rd Avenue in Grand, and you're like, what's that? Well, Grand is the road that you used to take to get to Vegas from Arizona. It was the pass. So some of you have probably been lucky enough to be on that. Hopefully you came back winners, but that's where it was. And at the time, there wasn't a lot of growth around it. So it's kind of isolated out. So when the passerby had called in that there was a check fire, it came out as a check smoke in the area. The captain on Fire Station 304, Sean Marty, very good guy, hazmat tech, just was not on a hazmat truck, excuse me. I knew him from a lot of our hazmat teaching and instructing. Said, man, this is kind of out towards a desert area. I'm going to bring the apparatus. So he brought a tanker with him. He brought their brush truck and their engine just to make sure that, hey, if this is the initial start of a brush fire, we have some resources there until we can get some people out, because it's a little bit out. They initially arrived on that scene, and I'll give you some of the thing. You can see hazmat engine 193 is kind of down there at the bottom of the strip. The reason why we got picked up on that is because Surprises hazmat unit 305 was actually on an additional call. So again, the way our system works is their hazmat unit that was the closest was unavailable. So it picked us up as an automatic dispatch once he balanced that call. So to give an overhead scene of some of this, and I'm going to kind of jam through, this is usually a longer presentation with a lot more interaction instead of me staring at my own face on a screen. So I do apologize on that. This is the overall area that you see. So when you see that Google map view, you can look across the street and there is an academy, but that Grand Road that you have going through there, that's like a major thoroughfare. Grand's like a abbreviated highway, smaller old school highway that goes in, but you can see that square in the middle, that's the transmission station. So we did know that that transmission station was there. You can see there's not a lot of exposures around. You'd have to go across that main thoroughfare. That was the biggest thing that we had, is the time of day was, hey, we may have to shut down a thoroughfare if we've got something bigger going on. This is a zoomed in view. So on the zoomed in view, you can kind of see the transmission station that's there, and then the small building that is sitting down there to the main, that's the APS building. Again, the only thing that we really knew that was going on was the concrete block that was there. So Sean Marty and his crew on Fire Station 194 or 304 get kicked out, and they get on scene. And when they arrive on scene, they have a smoke that they have going on. I've always referred to it as a white cloud, but there wasn't a ton of it. And they were like, man, this seems a little bit different. So they got in the scene, they started looking around. And as you can see that area, keep that in mind, this is when they first showed up on scene. And you can see there's really not a lot there. If you look on the other side of one of Sean's firefighters, you can see a little bit of smoke kind of back there towards the building, but doesn't look like a lot. And when he saw that, he said, this is coming out of this building. I don't know what this building is. It doesn't seem right. It's not acting like fire smoke should set. And then he said that there was a little bit of like a burning style of vinegar style smell, something like that, that was going on. And he said, I'm going to go ahead and balance this to a hazardous assignment. So he pulled his crew back. He also pulled back some of the workers that magically showed up out of the clear blue and was like, hey, I think something's going on in your building and we need to sit back. So he dispatched us. Now it comes into the happenstance of your career, right? You know, we go to these trainings just like a lot of you are here today. We send ourselves all around the country. We try to become experts in our field, and that builds us up. But really, you pull off those slides and you pull off the slides of the calls that you had. So as we got picked up on the hazardous call and it said, hey, hazardous assignment near APS transmission statement, it went back. And in about 2005, I'd been kicked out on first in truck on APS fire at one of their other storage facilities, actually on the 4th of July, and one of their major transformers for Arizona had caught fire, and that was burning. We were the first unit there, and the biggest thing that we had there was stranded energy, right? And we've got these power lines that are going through at an even larger transmission station than this. And we've got one of their huge transformers that's burning and blown, and it's catching the ones next door on fire. And APS is freaking out because it had already spread to 2 and was spreading to 3. And basically, if it had gone on past 4, it would have knocked out most of the power in the west side of Arizona on the 4th of July holiday. So they were screaming for us to get in there. So luckily, in that time back in 2005 range, right, that we were like, hey, we got to work with them, and we found out that outside of the power lines that were over top, really a lot of those big transformer things just have a lot of mineral oil in them, right? And that wasn't really hazardous, and we were able to work with them and get some of those things. So on our initial dispatch, as we do, we draw from those slides, and I'd said, hey man, if this is a transmission station, we're going to have overhead power lines. We need to be cognizant of that stuff, keep our area aware. But if this is a transmission or a former that is burning, we'll line our wire up over here. We don't have a lot of hazardous things that we need to worry about, and we can kind of knock it down and go from that point. Shortly into our drive and route, that's what we were kind of researching, going over. We were using overhead aerials that you had seen before, and we moved in, and Sean gave an update. He said, hey, this isn't at the transmission station. It's actually in a building next to it, and it appears to be some sort of energy storage system. And as soon as that came into play, I actually talked to my entire crew, and I said, hey, if this is at one of the energy storage systems and it's the lithium-ion batteries, there's a high probability that if these things are failing and not burning and they're actually in runaway, that this building can blow up. That was said almost immediately, and it's one of those things that stays in your mind. And what I always compare it to when we're going into play is much like when we have a house fire, right? If we have a house fire, a commercial fire, and it's burning pretty good and it's been rocking, the one thing that we're thinking about is, hey, that roof can always come in on us. But if our tactics, our objectives are being met, and we're having proper results come down, we're seeing reduction of the fire, the load, we're not having sagging, then collapse of that roof goes from being a top priority that could kill us that are on top of it or underneath it down to the bottom. Now, it can always collapse later, but we're saying, hey, if our tactics are in place there, but this is for the same thing for us as explosion started at the top. And the reason being is actually just a year before this incident, a place called Gruber's, which actually just burnt again a couple years ago, used to do a lot of work on retroing old Teslas and old electronic cars. Now, not saying they're Teslas, but they had a lot of Teslas in there. This was not a Tesla certified facility. And I have to say that because Tesla likes to make sure that that was not. And we aren't saying that. They just worked on lots of old school Teslas. And they burned and caught on fire. But this is actually burning, not just in runaway, but it started away with an arc and a runaway on those batteries. And again, by happenstance of all things, where the staging unit was coming and we were coming in on this massive second alarm fire that was burning in an industrial complex and had a hazardous component to it. By the way I had routed my crew in, we ended up being the response hazmat team. And we were there for about 4 to 5 hours working on that incident. And luckily that day, we're on the phone with the Tesla engineers the entire time. They were very friendly, talking about the chemistries that we potentially had to deal with, what we would find in some of the runoff and the water that was being sprayed onto this large commercial fire that was moving, that it's isolated in one building, some of the hazards that we would see on our meters, and all that stuff was going on. So just a year prior to this, I'd had a long call that was tying in. Now, that doesn't mean we'd had lots of access training, but just by situational things that we find our way in, I just happen to probably be one of the most experienced people on these types of fires in our Arizona system, and by other classes that we had gone to, which had really focused mainly on EV, not on battery storage components of those things. So as we started talking to those, we were doing our guys. So we started researching. Jump ahead to us showing on scene. And what I like to say is, I always told everybody there was this white cloud. It was staying about 3.5 feet off the ground. It was moving kind of like the ocean back and forth. And just for easy sake, the wind was blowing out of the north. So the cloud was moving to the south about 100 yards, and then it would dissipate and go away. So when we got there, they had isolated everybody out and were waiting for us to get there, which were the 3 or 4 workers that were there. The battalion chief and their crew had stood back to the side. When we got there, from those pictures, this is kind of that white cloud we're talking about. So this has been really a sign that we can see if there's not active fire, right? Or a free burning stage in not only our cars, electric cars when they're happening, but in our storage facility and the testing that we did with FSRI and everything else is that white cloud. It doesn't act like a natural smoke. It kind of stays lower. Now, if it's in a building, it does fill it up, but it tends to stay low, reverse fill and come out. Whereas smoke, as we know, tends to go up, bank down and come down. This is moving in a reverse order that's going on. But you can see that cloud. Those are the pictures that we're talking about. And we staged our units uphill and upwind from where it was moving and at. And we created initial hot zone. There's a lot of false information that initially came out that said, hey, we rushed in. Unfortunately, even the company said that and has continued to say that. It's some of the testing, which or some of their teaching. We did not rush in. The totality of this call was 3.5, 4 hours. Just before we made entry into the building, it had been 2.5 hours of us evaluating the time on the scene until that had happened. And if you think an hour before that, the incident that they never notified us on, we weren't in a rush like firefighters normally go charging into things, right? We knew something different was going on. And in the time, we made 5 different entries, but when I talk about that, the 4 entries were just into our hot zone. And our hot zone initially, as you guys can see, had expanded out from that building and into the desert, and we established an initial hot zone. So the first 4 entries were all just into the cloud outside. We actually only made 1 entry the entire time into the building, and that was the very last one we got to be there. So again, I'm kind of summarizing a lot of this to keep us in our time loop so I'm not wasting everybody's time and getting you there. But basically, out of our findings to kind of come into play was we were getting elevated levels of CO, CO2, depleted areas of oxygen. We're having extremely high areas and pegging out our meters on HCN. We were also using our tick cameras to tick some of the areas. And on the back side of the building, if you guys look in that upper left corner where you can see the 4 AC units, and I know it's kind of small on your screen, so I apologize there, but I'll try to move my mouse over. This area right here where you can see it moving if it's there, that was the only area where we had an elevated hot spot, and it was about the size of a vent, and it was about 140 degrees. It didn't really change. And again, if you think April 19th on this, a spring day that was there, and this was a little bit warmer, April 19th, 140 degrees on a metal building, not super crazy, but it was an isolated spot. It never grew. It never got smaller. It stayed there the entire time. So I always like to tell everybody, we were asking ourselves 2 questions. I had said this, are we dealing with a fire with hazmat or a hazmat with fire? And for those of you that are probably on here, you're probably as nerdy as I am with this stuff. And those are 2 different things. But when you say that to a normal person, they're like, who cares? That's the same thing. But they're very different to me. If we have a fire with hazmat, generally speaking, if we knock that fire down, we don't really have an issue going on with the hazmat anymore. But if we have a hazmat with fire, as we all know, a lot of hazmat has the potential or the ability to create its own heat and create its own atmosphere and that chemical reaction to continue to propagate that fire and make a small thing much bigger. And so that's what we were trying to figure out is, did we have a small fire that was knocked down that we're going and we're just dealing with the remnants, or do we have something else? The other thing was the stranded energy. So some of the energy that was in here, I told you it was next to a transmission thing. And that was one of the funny things that we found out is by doing research, it had said that these batteries should be filled to 70% of capacity. That was for the manufacturer's recommendation that we had going on. But when I was on the phone with their techs that they had that were at a different site and their engineers, the person had said, hey, I said, what do you store these batteries at? How much energy do we potentially have in there? And he said, they're at 90% of capacity. And I said, 90% of full capacity? He goes, yes, we keep them at 90% of full capacity. Sometimes they're a little higher, but that's what they were at our last readings. So when he said that to me, and I emphasized it multiple times, I said 90% of full capacity of the battery. And he was like, yes. After the fact and the incident happened, they've tried to say, hey, they were at 90% of 70% capacity. But I will tell you 100% those batteries were charged to the hilt. And that's what their engineer was absolutely telling us and going from there, which didn't worry us too much, but it did worry me on the potential power that was in there. And that's the big thing with these buildings is you should not be scared of these lithium-ion batteries. I think they have less than a 1% fail rate. The problem is that the potential energy that it is in there is so when they fail catastrophically in general. But we're all, half of you are probably watching this on your phone. Some of us are on our laptops, computers. There's lithium-ion batteries. Our kids are playing with it. We're not worried about this. We just haven't figured out how to fight this technology or work alongside it completely when it does go into fail. So through all that stuff, this cloud, and again, I'm giving you the super abbreviated version, so I really apologize. The cloud had been out. Well, over a period of time and those different entries and our readings going in, the cloud had gone from being way outside to just coming out of the building. We had been on the phone researching with other people, talking with their manufacturers, doing other things, trying to figure out, well, what's our plan? Because again, we bring a lot of the life hazard to this, and you saw there was no life hazard around. But what we did have is we had the 4 workers that were there with us, and they were really nice guys. They were awesome. They were trying to be helpful 100%. But they kept asking us the same question. They kept going, hey, when can we get our building back? Hey, when can we get in there? We need to figure out what's going on. When can we have our building back? And I said, hey, as soon as we're done with this, you can have your building back. But I know of the readings that I'm getting right now, there's a simple asphyxiant, a chemical asphyxiant that'll kill you right now because they're way above the IDLH readings. And we potentially have a fire and other things going on. And we have hydrogen that could potentially blow up that could be stored in there. Those were things. Now, we weren't able to test for hydrogen directly. And I guarantee that most of you don't directly have a cylinder just for hydrogen. There is a cross sensitivity between a lot of our CO sensors and even from our HCN sensors and hydrogen when you're looking at those. And depending on whose sensor it is, it's about between 1% and 20% generally in there on a cross sensitivity that can get stored in. And just like you saw in one of Alex's test videos that she was showing you, is when they layered it and it burned, it doesn't burn in this perfect layering, right? We have pooling in different areas as it has to go out. And this was not an airtight building. So it was kind of, because that's how everything was getting out. This hydrogen was caught in some of these areas and wasn't just able to escape up to the atmosphere like we would love to hope. But we finally get down to the point and the call comes in and I said, hey, I don't trust that if we turn this building over, these guys aren't just going to turn around and walk in. That's essentially where we came down to. So we had a life hazard of them potentially going inside. And I did not feel comfortable turning a building over to somebody when there was a potential that I felt if they opened the door, they were going to be in big trouble. So we finally get to the point and I said, hey, we come up with 2 plans. And these were our 2 plans. I said, we've got this building. If we've got a battery and thermal runaway in there and it's actually trying to fire, maybe the Novak system knocked it out. I said, we'll go up there, we'll monitor around the building because everything had gone from being way out to isolated just into the building. I said, we're going to monitor around. If it's just isolated the building, which it was, we're going to crack the door. I think the fog's going to come back out, right? That cloud, we'll test it. It'll be similar. If that gives it the oxygen that it wants, the fire will start back up. We'll hit it really quick with the nozzle, back out, and we'll burn this building down. In about 6 to 8 hours, we'll all get to go home and this building will be non-existent and we'll all be good in place, right? I said the other thing is, and hopefully the better one, is that the system has actually shut it down and this battery isn't in runaway and the fire has actually been put out. Same principles apply. We're going to open the door. The cloud's going to come out. We're going to tick and do all that stuff inside. The fire's not going to start back up. We're going to leave the door open. We're going to back out. This thing is going to passively vent. And in 2 to 4 hours, we're all going to get to go home and we can turn this building back over and then they can do any of the repairs. Those were our 2 things. The company was there with us. They were very on board with that plan. Everybody that we had talked with was on board with the plan, said, cool. I said, here's the deal. You guys are going to stand to the outside. We're going to make entry. So as we kick over, you can see now it's nighttime. That cloud isn't really there anymore, as you guys are seeing. So it's much clearer. I take my crew up. We're coming in. These pictures were taken by some of the people outside. And I said, hey, we're going to monitor around this building because now you can see that that cloud has isolated the building. But I always knew in the back of my head that still this thing could blow up. So we need to be cognizant of those things. So I said, I'm going to be the person that opens the door. My crew is going to stay back. I had my booter nozzleman, which my booter on my truck, because there's always a boot on the truck. He had 3.5 years on the job. So he was our junior guy. And I had him back on the nozzle. I said, hey, if this thing flashes, hit it. We're backing out. So we get into those areas. I set my crew up and we go to make entry into the building. It's around 8 o'clock when we go to make entry. And as we open that door, after we'd cleared the building on the outside, exactly what happened. I had monitored and said, we're going to open outside. We open the door and the cloud starts coming out. So you can see I've got the open door. That cloud is coming out. My engineers on the backside, I stepped out to say something, make sure that they could get my radio communication. And then I walked back to the front of that door. We'd already been metering it. So it went from almost nothing to being back in that area. I also stepped across the threshold. We were not inside, just to tick the inside of the camera. So as I stepped across the threshold, I ticked down that storage facility, came back. And my last transmission that I came up with was 104 degrees, no active fire. And that was the last transmission that I made. I told my crew, hey, we're going to back out. and we're going to let this thing off gas. And as my crew was starting to back out, and I turned this way, and something in my tick camera went like this. And I go, what was? And as I turned back around, it went boom. And that's when I ate the entire explosion. And that's one of the things with the lithium-ion batteries, is in our tick cameras being less than effective, is they can go from being at a temperature that's not doing anything to full burn thermal runaway and touching off all the other that cloud of toxic gases that are there and combustible gases like right now. And that's the difference. So our ticks aren't as effective as we would like to think they are, because our ticks are used to watching things burn at a steady rate. This is a right now reaction and where it comes to be. So I ate that explosion and went backwards. I'm kind of hit and miss for about the next 2 months during that time on what I can tell you of the incident. A lot of that comes from there, but this is what the building looks like after the fact. So you can see that same building that was burnt. It's completely bowed out as what you have going on. That's the green door that we were entering. It was ripped right on. You can see our hose line that was off to the side there. The good thing on this entire area is I always try to tell everybody, hey, whatever you tell your booter before you go in, they listen to. So my 2 firefighters off to the side, including my my booter, not my probationary guy, that were on the line, got blown back about 8 to 10 feet. This fence right here, it's about, I don't know, about 20 feet back from the building, something like that. So I hit that building, then went through that, bounced across the desert, continued to go, ripped my gear off, all that stuff. And I landed another 83 feet out past that in a burning bush. And I was on fire in the bush, right? And my engineer got knocked back just to the other side of that fence also. And he was unconscious. So that's the bush out there. There's my red helmet sitting in there, and there's the bush that was burning. And that's where I was sitting there. You can see the destruction on that building. Well, when my probationary, or my booter firefighter, sorry, we have a bunch of probationaries. I've been doing probationary training all week on our people, so it's stuck in my head. When Jake came back to, he looked at the building and it was smoking. And he's like, well, I don't see any fire there. And he looked to the left and he said, oh, there's fire. Capt told me to put that out if I hit it. And he put it out. And good thing he did remember that, because that was me burning in the bush. So had he not put me out, potentially I wouldn't be here getting to talk and share this story with you. But that's kind of some of the aftermath. We were lucky enough, you know, to have UL come in and be willing to do an after action report. Most of you guys know our after action reports, unfortunately, are when people have died. I get to travel around and tell a bunch of people how I almost killed my crew, which isn't always the most fun thing, but I want to keep our fire service safe as to where we're going from in those areas. I don't share my crew's injuries, except for the fact that one of my guys has been forced to medically retire. My other 2 are back on the truck. One's been promoted to captain since then. The other one's still on the hazmat team. Well, they're both still on the hazmat team, but the other one's got a full-time station on one of the other trucks there. My engineer, he promoted to captain now, and he's actually in my old position. I am not cleared to go back to the truck. I'm actually sitting in a training captain, but I will share my injuries with you, so you know that. But our other firefighter, Cotini, he was forced to medically retire due to the injuries that he sustained on that. So the injuries that I sustained is I had a TBI. I have an issue with my vision field that's going on. So my vision field is to about there on this right side that I can actually see something again. So it's a little bit off. I broke my neck T4 through, or C4, 5, and 6. I broke my back T4 through T9. I shattered my scapula into 5 pieces. I broke ribs. I had some internal bleeding going on there. I broke my hands. I had burns to my hands, face, neck, head, also to my legs. I amputated basically both of my feet completely off, the thing that kept them in, where our fire boots kept my feet together. So they were able to put, reattach my feet and all that stuff on. So I have a lot of metal through that area. Broke my feet, amputated my feet, also burns down my legs and through those types of areas through there. So altogether was in between the ICU, the burn center, and the rehab center. It was about 2 months before I got to go home. My engineer was roughly the same time with me. You know, we've been able to come back and try to teach and make this thing smart. And again, it's one of those things, we have a lot of these incidents happening. You heard Evan talk about the cars, right? We've had a lot of incidents with actual car and batteries burning out here. We have recycling units, like a bunch of you guys were showing in Ohio up there. We've had some incidents on batteries at those ones. We've obviously had some energy storage ones. We've had residential energy wall failures due to fires and a failure, actually. And those are very hard because it's on the other side of the meter. And once it's on the other side of the meter, the utility companies don't deal with it, and the insurance companies haven't figured out what they're going to do and how they're going to mitigate a problem on those walls that are here. So we've had lots of these incidents all the way around. We're trying to get better at them. I really want to thank all the companies that are out there that are trying to work alongside with the fire service to make this stuff better for all of us. But ultimately, at the end of the day, that's the briefest, rough rundown of the story. You have some very smart people here with this. We'll answer some questions, and I'll answer anything that might come up. I don't know where I put my screen. There I am, and I'm back. But that's the rundown, and we can answer any other questions, in regards to what we were thinking on the incident, where it was. But this is a technology that's there. It's a technology that's going to help the grid overall. But as I've always said to everybody, I'm big on this stuff. I want to support it. We want to push it. We've actually made some big changes on our fire code here in the state of Arizona. Again, a lot at the local level. We've increased what we thought. The companies have tried to work well with us. We've put in some of our recommendations for monitoring that's on the outside of the buildings, obviously, venting systems that will hopefully allow that to go up. We do know some of the testing that was right after this done by UL on a different test that Alex didn't show today. They tried to show some of the deflagration panels and things like that, and they don't always work exactly like they want them to, but we were looking for areas to try to figure out how can we make these types of areas safer. We've put some very strict codes in, especially in Surprise, Peoria, and the Phoenix greater area here. However, just to be honest with you, I've already seen exceptions written in our own city, written in a lot of other areas in our city, because money greases the wheels, right? People are in these, they know the right one, and they're getting exceptions written. So a code's only as good as those that are willing to like really hardcore enforce it. And unfortunately, a lot of us are governed by, councils and everything else and city ordinance that are above us, and they can make exception to those rules and take that stuff in. And then ultimately, we're still the mitigation plan. As long as the fire department continues to be the mitigation plan, I think industry has an obligation to really try to communicate with us. Unfortunately, this technology is moving so fast that I think as soon as we start to figure out something, we're dealing with something else coming in. But I think we're really on the cusp of giving you guys some very good pointers, some tactical considerations that you've got. There's lots of stuff going on. New York's doing a lot of things. Companies like FSRI with UL are out there banding together with us and pushing these types of things, putting these conferences together, sharing our experiences, and ultimately trying to make sure that we all get to go home to our families. That's what this is about. Nobody wants to die, trying to protect a vehicle or a building. Unfortunately, sometimes that can happen, and that's what our job comes down to. But I really thank you guys for sharing me today. There's probably some questions, probably for the other smarter people, but that's the down and dirty. Hopefully that gives you a reality of what we can deal with. So thank you.
All right, we want to give you one last chance to get all your questions in the chat. I did have a question about providing a link to the codes that are being referenced. I don't know if we can do that quickly or not.
I don't have them right now, but I can definitely send them to you guys if that's cool, to show some of the stuff that has been updated in the Arizona area. Again, it's all unique to your guys' regions, just like Evan was talking about in New York. Some of his things are different than what you guys will have, but I have no problem trying to get those together, and I'll send them over to you, Jack, if that's all right, and you can get them out to everybody. Cool with that?
Sure.
If you want to stop sharing, Hunter, I think we're still seeing your screen.
I'm sorry, I didn't hit that other button. I apologize, sir. There you go.
No problem. No problem. Back to you, Jack.
All right. Well, I am just for a minute. So we'll get Alex and Evan back on here too. But while they're getting back up, I'm going to just throw this QR code back up here again real quick. So if you didn't get a chance to hit that QR code with your camera phone to go to the link for a couple hours of Con Ed, please do that now. We've also loaded that WebOFA link in the bottom of in the chat a couple times. I saw Alex putting some other links in there for FSRI. If you folks haven't gone to UL, years ago it was UL University, and now FSRI has got a ton of stuff on there. Lithium-ion batteries. Even just last year, we were fortunate enough to hold host the UL Fire Dynamics Boot Camp here for FEMA Region 5. And, just the work that they're doing on modern fire dynamics with the heat propagation with all the petroleum-based plastics in our fit and finish, interior fit and finish now. I would urge you guys strongly to stay up to date on new firefighting tactics and strategies because of those dynamics that change our fire scenes on a regular basis now. So I'll stop sharing that so we can get some people up here. So I'd seen some different things in the chat, but we're going to open this up also just verbally as well. So I know we're a little bit over time, but we're happy to stay on. If anybody wants to use the raise a hand feature or just open up and ask a question, then we're happy to answer that.
We may have hit all of them as we were interrupting each individual
Mhm.
presenter, but
Yep.
it doesn't look like we have anything that we missed.
Okay. Good. We did get one request to put that QR code back up. Let me see if I can do that. They said try to do it on full screen. So Adam or Andy, can you see that as a full screen, the QR code?
Well, I have all of our presenters spotlighted as well, so you're most of the screen.
Okay.
It's like 2/3.
Jack, do you mind if I just hop in real quick for 1 second?
Yeah, go ahead. Yep.
Hey, first, thanks for having me. I appreciate all the info here. We are building a lot, so we work with FSRI and UL, and all the information we bring in. We're trying to share this nationwide. This is something that everything we learn, we share. So even if your firefighters have anecdotal evidence and they've operated on an EV fire and they saw a different type of battery react differently, it'd be great to get that information. So if there's a way for feedback to get to me, I don't know if anybody else is able to take it, but we really try to change our presentation through the FDNY and through the battery symposium to what we find. We have a whole separate single mobility device presentation. It's different and focused on the batteries and how they react, and they're smaller. We can share that too, but we like feedback. If I said something that somebody disagrees with, honestly, reach out. I'll have the conversation. I'd like to change because we're going to share this somebody somewhere else, and we want to give the right information. So just that little.
Yeah, thank you. Absolutely. Any other closing comments or questions?
Nothing in the chat, just some thanks and a lot of appreciation.
Okay. Well, good deal. Well, I think that's a wrap then. Again, thank you everybody for participating. I'll go ahead and leave that QR code back up here for a couple more minutes for anybody that wasn't able to get that. And again, you can use that web OFA link to shoot any questions to us, and I'll make sure that our presenters get them if they're, if they're pointed at Evan or Alex or Hunter, and we'll be that pipeline for communication to get that to them. So again, thanks. Stay safe, everybody.
Thanks, everybody.
Thank you.